Hi friends, in this tutorial I am planning to write a binary search tree from scratch. So let's get started. This is in C language, so we need to include stdio.h, stdlib.h. Then we need to create node. So we need to declare a structure for binary search tree nodes, and I'll say this is BST node. I'm type defing it. Currently I am storing integer kind of data. So payload is integer data and a pointer to left and right. So struct node star left. Similarly, I should have one right child pointer. So this is right, and then I'll declare our BST tree. So this I can say BS tree, and it will have nothing but pointer to the root of the tree. So BST node star, I'll call it root. Then we need to initialize BS tree. I can call it, let's say, BS tree, and the argument will be binary search tree BST. That's all. We need to initialize root to null. Root is equal to null. Then how we are going to use it in the main. So basically we'll keep on inserting the elements, declare binary search. Let me call it B1 and let me initialize it B1 by reference. After that we need to keep adding the element B1 comma 10. Like this we need to have multiple elements, 6, 7. Let's say these are 6. Then 80. And let me say 12. And once inserted, I would like to display the binary search tree. That's all. Display. I'll use Inorder traversal to display the tree. Till here we are fine. Let us try to implement insert and display functions first, and we will discuss about delete operation later. So insert BS tree and data which we want to insert into the node. Then we would also have display function which will have only BST as argument. So let us try to implement the insert first. So first we need to check if BST is empty. If it is empty, we will print info error message. Tree is, I can say, BS. And after that we can return. No. I think we need to create the element. So if it is empty, then BST root will be equal to create BST node. We need to create the node, and we need to pass data to it, and we need to return after this. So we'll have to write create BST node function. So let us write it. and this will return us bst node pointer to bst node. So let us write bst node temp equal to malloc. We need to allocate size of the node. Size is bst node, and after that we need to typecast it to bst node star. After that we need to check if memory allocation is successful. If it is not, then it will return null. We need to print error and return null. If malloc is successful, then we need to add the data. Temp data is equal to data. Temp left will be equal to null, and temp right is also equal to null, and we need to return temp. So this will create a bst node and will return the reference. If this is not the first node, then we need to traverse and find out the correct location of the data in the binary search tree and insert it there. So for traversing, let us take one current pointer, bst node star current equal to, initially it will point to root. We will use the current pointer to traverse through the binary search tree to reach at the correct location where we want to insert the data. So initially it will be pointing to root. Then we need to compare our data. If it is less than current data, then we need to move to the left side of the current. That is, we will update current equal to current points left. So here, before modifying current pointer to left, I need to check if current left is not null. If it is null, we need to create a new node there. So I'll have to add that condition. If current left is not null, then we can update the current pointer. Else, we need to create a new node on current's left. Create bst node data. So this is the correct position where that node needs to be inserted. So once we create node, we need to break and come out. Similarly, we need to check for if data is greater than current data, that is else part of this if. Here we need to check if current right is not null. If not null, then we can update current equal to current points right. If right is null, then we need to create new node and insert new node here. So we need to use create bst node data. And once the node is inserted, we need to break out of the loop. So this is end of while. Let us once try to compile and see if there are no compilation errors. .c -o bst. So warning, type of data defaults to int. Yeah, we need to type data type. Let me compile once again. Yeah, so it works fine. Okay. Let us now write display function to see what data is stored in binary search tree. Now to display the elements of the binary search tree, if we traverse it in the in-order traversal, we will get the sorted list. And in-order traversal can be done in recursive way and non-recursive way, that is iterative way. Recursive way is easy to write it in a recursive way, and let us see whether the elements have been inserted correctly. So here we first check if tree is not empty. If tree is empty, we'll just print the message and exit. Info message and exit. Else we need to do in-order traversal. So I'll call, let's say just for the simplicity, in-order, and I need to pass the root of the tree. And we'll have to write this function for in-order traversal. The data type of this will be, argument will be BST node. Let me call it say node. Anything is fine. And nothing I am returning. And in recursion we need to first traverse the left one, then visit the element, then traverse the right child. It will be in order. Let me node points left. This is visiting the left child. Then once the left child is visited, we need to visit the root element. So while visiting element, we need to print it. Node points data. Once the node is visited, then we need to visit the right side of the node. That is, we need to write in order node points right. And let us print a message here. The elements in the BST. Now let us try to compile and see if things work fine. Yeah, it looks fine. Let me clear the terminal. Let us execute the program and see if it works fine. BST. And there is segmentation fault. Let's try to debug it. We need to check here when we reach a null. If node is null, we need to return. If node is null, we need to return. And yes, the elements have been displayed. Let us check once if elements are correct. 3, 5, 6, 7, 10, 12, 20 and 80. So as we see, the elements are sorted because we have used in-order traversal for the binary search tree.